Hi all, welcome back to software engineering course. Let's get started. In the last class we had seen till prototyping model. Today we'll see about iterative development model. So there are two variations in this one. The first is iterative enhancement model and the second is iterative delivery approach. First we'll see iterative enhancement model. In this model what happens is the entire project development is divided into iterations. Okay, so one iteration will consist of the designing, the implementation, and the analysis of this iteration. And once it is done, the second iteration start. Again, in the second iteration, development, design and development or the another subset of the functionalities is done. Analysis is done for that, and this cycle continues. This iterative enhancement model, it tries to combine the benefits of prototyping and waterfall model. The basic idea here is to develop the software in increments. Okay, now each increment will add some capability or functional capability to the system until it is developed fully. At each step, extensions and design modifications can be made. In the first step, a simple initial implementation is done for the subset of overall problem. Now this subset is one that combines some of the key aspects of the problem that are easy to understand and implement. Again, in this model, it has a project control list. Now this list, it is created in this model that contains all the tasks that must be performed to obtain the final implementation. Now this will minimize the chances of error and reduce the redesign work. Each entry in the list is simple enough to be completely understood. Okay. Each step, each iteration here, it consists of removing the next task from the list, designing the implementation for the selected task, coding and testing the implementation, performing an analysis of the partial system is obtained after the step. Now the advantages of this is it allows changing requirement, not having the all or nothing risk in this model. The disadvantages here is the requirements for the future iterations are not known. The design of the system may not be too robust. Another disadvantages here is changes may have to be made to the existing system to accommodate the requirements of the future iteration, leading to extra rework and or discarding the work done. That means, say suppose in the first iteration, okay, in the first iteration you have developed some functionalities and you have analyzed it. Say for in the fifth iteration you are building some functionality. While building that functionality, this the functionality developed in the first iteration might be modified, or it can be changed fully, or it can be even deleted or discarded. So this is another disadvantage of this. Next we will see about iterative development delivery approach. Now in this, what happens is the requirements and the architecture design. The requirement and the architecture design is built in a standard waterfall model or prototyping approach. That means once the client gives the requirements, he gives the his needs. So that could be changed into requirements and architecture design. Now this, what happens here is the entire specification has to be created first and the architecture design has to be done. Now this thing, requirement and the architecture design can be done in a waterfall or prototyping approach. Again, once this is ready, that is the work product or deliverable of this phase is the requirement specification and architecture document. Once this is ready, then you can build the software, the actual product. Now this actual product building can be done in iterative manner. Okay, now the that means the building of the system, which is the most time consuming and effort consuming task, can be done iteratively. So in this approach, it's as good as having one iteration of delivering requirements and architecture design, and further iterations consisting of the development of the product. At the start of each delivery iteration, which requirements will be implemented in this release are decided, and then the design is enhanced and the code is developed to implement the requirements. The iteration ends sorry the iteration ends with the delivery of some working software system which provides some value to the end user. They can see the look and feel of the system. Selecting of requirements for an iteration is primarily based on the value of that requirement, how critical the requirement is. Getting it? First, what happens? The user needs will be written down into SRS and architecture design is done using a waterfall or prototype model. Now, the work product, that is the SRS and architecture document is taken and the actual product is built. Now, this actual product building will be done in iterations. Okay. Now, while building the iterations, you should be knowing the requirements. This requirement selection will be done by the clients based on the criticalness of that requirement. Again, the design can be enhanced, it can be built, and it can be tested. So once one iteration is completed, the next iteration will get started, and like this the entire product is built. Okay. Now we'll see the advantages and disadvantages of this. The advantage here is the requirements are mostly known upfront. Feedback from one iteration can be incorporated in the next iteration. Not having the all or nothing risk. Overall view of the system is available here. Again, hopefully, rework in the development iteration will be less. Disadvantage here is it is not suitable for changing requirements. More management attention is required here, and it is not suitable for the smaller projects. Now, in this RUP, what happens is the software will be divided into cycles. Each cycle delivers a fully working system. Okay, each cycle is executed as a separate project whose goal is to deliver some capability to the existing system. Now, each cycle here is broken down into phases. The first phase is inception phase. The output of the inception phase is the milestone is life cycle objective. The second phase is elaboration phase. The output of this is life cycle architecture. Okay, now this elaboration phase is again divided into iterations. Next, the third is construction phase. The milestone here is initial operational capability, that means a working product. The next phase, fourth phase, is transition. The output of this is product release. Now we'll see how these inception or how these phases will work. Now, the purpose of the inception phase is to establish the goals and scope of the project. And once this phase is completed, the life cycle objective milestone will be produced. This milestone should specify the high level capability of the eventual system. Next, we have the elaboration phase. The architecture of the system is designed here based on the detailed requirement analysis. The completion of this phase is the lifecycle architecture milestone. The designing is done here. The SRS is done here. Okay. Next, we have the construction phase. Here, the software is built in iterations and tested in iterations. This phase will result in a software product to be delivered along with associated work products such as user manuals, test reports, etc. The last phase, that is the transition phase. Now, the purpose of this phase is to move the software from the development environment, that is your environment, to the client's environment. Okay. Additional testing like conversion of the old data for this software to work, training of the client side people, etc. are done here. The successful execution of this phase will result in achieving the milestone called as product release. The advantages of these are efficient use of resources, improved control, improved risk management. And the disadvantage is process may be complex to implement, and this RUP requires expert to fully adapt to this process. Next, we'll have a quiz. The question is, which of these is not one of the phase names defined by the Rational Unified Process Model for software development? Which of these is not one of the phases which is present in RUP model? You have 2 minutes of time. Next we will see about time boxing model. So in this time boxing model, the basic unit of development is a time box. This one, TB1, time box 1, time box 2, 3, 4, and this can be any number of time boxes. Okay, so the basic unit we call here it as a time box. Again, this time box, it is of a fixed size. Remember, each time box is of fixed size. Okay, now again each time boxes, this is one time box, right? Again this is divided into sequence of stages. Now this sequence of stages can be approximately of same length or same duration. Now these stages, suppose here say time box 1 is divided into 3 stages. One is requirement stage, one is the build stage, and there is deploy stage. Now this requirement stage will produce some specific output. Build stage will produce some clearly defined output, and deployment is also same. The team for the stage performs only the task of that stage. Suppose whenever a project comes and say suppose you want to implement this time box model, so you will divide your human resource into requirements team, then we have development and testing team which will come under this build, and then we have deployment team. The deployment team, what they do is from your environment to the client environment, they will transfer the product. Okay, now this line, the team of for a stage performs only tasks for that stage. That means once a team which has been assigned to the requirement phase, they will only deal with the requirements. They do not deploy or they do not build the software. Next, build team, what they will do is they will only develop and they will test the product. They will not either do the requirement analysis or deploy. Consider a time box consisting of 3 stages: the requirement specification, the build, and the deployment. The requirement stage is executed by the team of analysts and it ends up with the clear prioritized requirements. That is the high level design along with the SRS. Now the build team, as we all know, it builds and develops the code and tests them. Deployment will deploy the product. Now when the requirements team has finished the requirements for time box 1, what they'll do is they'll move to the requirement preparation of the time box 2. Getting it? First, in the time box 1, the requirements team will analyze and build the SRS as well as the design. Next, what they do is once they have finished the work, they'll move on to the requirement analysis of time box 2. Now, when the build of time box 1 is completed, the code is handed over to the deployment team and the build team moves on to the build code for the requirement of time box 2. It is like this. Suppose once the requirements team has finished the requirements of the time box 1, they'll jump on to the requirement analysis of the time box 2, and once they have finished the time box 2 requirements, they'll jump on to requirements of time box 3. Then when the time box 2 is in progress, requirement analysis in progress, the build team of the time box 1 will be building and testing the product. Once the building has been completed for the time box 1, the build team moves on to the building, that is the development and testing of the code for the time box 2. Now when the build team is in time box 2, the deployment team of time box 1, they'll deploy the code and this process continues. Okay. At most 3 iterations can be concurrently in progress in this time boxing model. If we consider the time box, suppose this time box is of T size, okay, then the first software delivery will occur after T days and the subsequent deliveries, it will take place after T by 3 days. Getting it? Now the advantages here are shortened delivery time and this speeds up the development process. Disadvantages here are project management becomes complex. It is not suited for the projects in which the entire development work cannot be divided into multiple iterations of equal duration. Next we will have a quiz. Okay. Before that, this is the same. The requirements team. The requirement team, what they'll do, they'll requirement analysis for the time box 1. Once that is finished, they'll move on to the requirement analysis of time box 2, then 3 and then 4. Once the requirements team jumps on to the requirement analysis of time box 2, the build team comes into picture and they'll build for time box 1. Once it is finished, they'll move on to time box 2. The same thing happens for the deployment team. We will have a quiz now. Say true or false. In the time boxing model, the time boxes are of fixed duration. You'll have 2 minutes of time. Okay, time's up. That's it for today. We'll conclude our session. Thank you.